Understanding classical mechanics and Newtonian physics involves grasping the fundamental principles and laws governing the motion of objects. Classical mechanics, formulated by Sir Isaac Newton in the 17th century, laid the foundation for our understanding of motion, force, and energy. Here's a step-by-step guide to help you comprehend these essential concepts. 1. Start with the basics. Definitions. Familiarize yourself with key terms such as force, motion, velocity, acceleration, mass, and inertia. A clear understanding of these terms is crucial for delving into classical mechanics. 2. Newton's laws of motion. First law, law of inertia. Understand that an object at rest will remain at rest, and an object in motion will remain in motion unless acted upon by an external force. Second law, law of acceleration. Comprehend the relationship between force, mass, and acceleration, as expressed by the equation F equals ma. Third law, action and reaction. Recognize that for every action, there is an equal and opposite reaction. 3. Vector operations. Vector basics. Grasp vector quantities, which have both magnitude and direction. Force, velocity, and acceleration are vector quantities. Vector addition. Learn how to add and subtract vectors, as motion in physics is often described by vectors. 4. Kinematics. Describing motion. Study kinematics, which deals with the mathematical description of motion. Understand concepts like displacement, velocity, and acceleration. Equations of motion. Familiarize yourself with the equations of motion for uniformly accelerated motion. 5. Work, energy, and power. Work-energy theorem. Understand the relationship between work done on an object and its change in energy. Potential and kinetic energy. Differentiate between potential and kinetic energy and how they relate to an object's position and motion. Power. Learn the concept of power as the rate at which work is done. 6. Momentum and collisions. Momentum. Understand momentum as the product of an object's mass and velocity. Recognize the conservation of momentum in isolated systems. Impulse. Learn the concept of impulse as the change in momentum. 7. Circular motion. Centripetal force. Comprehend the centripetal force required to keep an object in circular motion. Angular displacement and velocity. Understand the angular counterparts of displacement, velocity, and acceleration. 8. Gravity. Law of universal gravitation. Familiarize yourself with Newton's law of universal gravitation, which describes the force of gravity between two objects. Gravitational field. Understand the concept of gravitational fields and their influence on objects. 9. Free body diagrams. Identifying forces. Learn to draw free body diagrams to identify and analyze the forces acting on an object. Equilibrium. Understand the conditions for equilibrium and how forces balance in static situations. 10. Applications and problem solving. Real-world examples. Apply classical mechanics to real-world scenarios, such as projectile motion, planetary motion, and simple machines. Problem-solving techniques. Practice solving problems using the principles and equations of classical mechanics. 11. Continuous learning. Explore advanced topics. If your interest deepens, explore advanced topics such as rotational dynamics, fluid mechanics, and wave mechanics. Historical context. Understand the historical context of classical mechanics and the contributions of other physicists, such as Galileo Galilei and Johannes Kepler. 12. Resources and tools. Textbooks and online resources. Utilize textbooks, online courses, and educational websites to reinforce your understanding. Simulation software. Experiment with physics simulation software that allows you to visualize and simulate various classical mechanics phenomena. 13. Practice and experimentation. Hands-on activities. Engage in hands-on activities and experiments to reinforce theoretical concepts. Laboratory work. If possible, participate in physics laboratory work to apply theoretical knowledge to practical situations. 14. Seek clarification. Ask questions. Don't hesitate to ask questions and seek clarification from teachers, professors, or online communities if certain concepts are challenging. 15. Stay curious and appreciate the concepts. Curiosity. Cultivate a curious mindset and approach classical mechanics with a desire to understand the fundamental principles that govern the physical world. Appreciation. Appreciate the elegance and simplicity of Newtonian physics in explaining a wide range of natural phenomena. By systematically approaching classical mechanics with these steps, you can build a solid foundation in Newtonian physics. Remember to be patient with yourself, as these concepts can be challenging but incredibly rewarding to understand.